Right. Go throw pencil. All right, we're going to talk about angles and secants today in circles.
Are your notes on your website, right?
They will be. They're not on there right now.
Yeah, obviously you can write them, but I mean, like after.
I could save them from last year.
You always put like our classes recording on there.
Yeah.
Can we watch, instead of taking notes today, can we watch your video from last year?
No, what you should do is take notes and watch my video from last year.
But we don't have time for that.
I need to listen to video because you go to class.
All right, so first thing we need to do is resign yourself to the fact that we're learning geometry this afternoon.
Alright.
And now we're going to learn it. All right, secants. Let's stop talking, guys. Let's focus. Learn to feel the joy in your mathematics. Secant is a line or a segment or a ray that intersects a circle in 2 points. I'm going to say a line.
Go to the barbecue tonight?
I can't go to the barbecue.
You can?
I cannot.
Is it date night?
Bring it on Monday.
Bring it to class so you can take it.
Yeah.
And then I'll sign it.
Bring your wife.
Perfect.
To be your date.
So our secant, the secant line intersects our circle in 2 points. So what we get in this piece of the secant is a chord. And what we're going to do is talk about secants and different ways they can intersect, and the angles and the arcs that, and the lengths that come about because of intersecting secants. Secant means to cut in Latin. So it means so the line is cutting through the circle. All right, so the first thing that we're going to talk about is angles and arcs. So secants can make angles in circles in a couple of different ways. Now I want to emphasize today we're talking about our vertex of our angle is not at the center of the circle, and it's not on the circle. So these are different than what we've been talking about. So what we're talking about today is angles. The vertex of our angles today are not at the center of the circle, and they're not on the circle.
So they're
In the circle or outside the circle. So one of those two. So students often get confused about the different rules because we have different rules for different things. All right, so our first example is going to be that our lines intersect inside the circle. And I'm going to say not at the center. So our picture here looks like this. And here are my two secants. And they intersect inside the circle here. And I'm going to call this angle 1. And I'm going to call this x degrees and this arc y degrees. And what we're interested in here is a relationship between the angles and the arcs. So for this first one, when our lines intersect inside the circle, the measure of angle 1 equals x plus y divided by 2. And the way I think about it is the angle equals the arc plus the arc divided by 2. Angle equals arc plus arc divided by 2. these two arcs, the two intercepted arcs, and the angle that we're talking about is this angle here. So that's the one inside the circle. This is the one way that things can happen. All right, we good there? All right, the next thing we're going to talk about is angles, or the lines intersecting outside the circle, and that can happen in several different ways. So we have three possibilities here. So I'm going to draw three circles. All right, so our first possibility is we could just have two secants that intersect outside the circle, like so. And again, I'm going to call this angle 1. I'm going to call this x degrees, and this arc y degrees. So we could have two secants. I could have a secant and a tangent. So we could have something like this. And this is angle 1, and we call this y degrees, and this arc x degrees. Oh, sorry. All right, so we can have a secant and a tangent. And the other possibility is we could have two tangents. So that would be something like this and something like this. And we're going to call this angle 1, and this y degrees, and this x degrees. And what we're interested in is how the angle and the arcs are related. Well, all of these where the lines intersect outside the circle have the same rule. I'm going to say the measure of angle 1 equals x minus y divided by 2. The big arc minus the small arc divided by 2. And the shorthand that I use here is the angle equals the arc minus the arc divided by 2. So when our secants intersect inside the circle, the angle equals the arc plus the arc divided by 2. When the lines intersect outside the circle, the angle equals the arc minus the arc divided by 2. When the lines intersect outside the circle. Yeah. All right, we good there? Okay, no problem. Doesn't this look like a nice base? All right, we good? Okay, let's look at a couple of examples. Now, when we do our test over chapter 12, we have a note sheet that has these formulas written on the note sheet for the different situations. So you have the formulas that you'll be able to use. And the same for the inscribed angle. The angle equals the arc divided by 2, etc. Well, those will be on the sheet as well. All right, so let's look at a couple of examples. Here's our circle. Here are our secants. We're just going to draw a section of the secant, which gives us 2 chords. And we'll say that's x degrees, 87 degrees, and 165 degrees. And we want to find x. So here we have 2 secants, or portions of 2 secants that intersect inside the circle. So what's our rule? Angle equals arc plus or minus? Plus arc divided by 2. Plug the different pieces into the formula and calculate. Angle x equals the arc plus the arc, 87 plus 165 divided by 2. 87 plus 165 is 252 divided by 2, and I get 126 degrees. Easy, right? Questions on that one? All right, I want to look at one now where we have to kind of work with the formula in reverse. So here are my 2 and we're going to say that's a tangent, and this angle is 22 degrees. This arc is x degrees, and this arc is 98 degrees. And again, we want to find x. So our lines now are intersecting outside the circle. So our setup here, angle equals the arc minus the arc divided by 2. Now we have to be careful here. What's our angle? 22. So 22 equals the big arc, 98, minus the small arc, x divided by 2. So I'm just plugging everything into the formula. This one we're solving for an arc instead of an angle, so we just have to do a little more work. So now how do we get x by itself? Multiply everything by 2 to get rid of that 2 in the denominator. So those cancel. 2 times 22 is 44, equals 98 minus x. All right, what do I do next? Subtract 98. So I get 44 minus 98, so I get minus negative 54 equals negative x. So x equals 54. You can divide by negative 1 or multiply both sides by negative 1. We get x equals 54 degrees. So I had to work kind of in reverse there. All right, questions there? Okay, let's look at one that's just a little trickier setup. Here is our circle this time. And we want to find x. But all we know is that angle. Any ideas? Let's think back to what we did in the opener. If this arc is x, how do we figure out how big this arc is? What do we do on our opener? Now, remember, the multiply by 2, divide by 2 only works if our vertex is on the circle. But in the opener, we knew 1 arc. How do we find out what does the entire circle make? How many degrees? 360. What if this was 20? What if this was 50 degrees? How would we figure out what this was? 360 minus 50. So if it was 100 degrees, this would be 360 minus 100. So if this is x degrees, how many, what is this? 360 minus x. Now we know both arcs, right? And our segments intersect outside the circle. So the angle equals the arc plus or minus? Minus the arc divided by 2. So I'm going to plug my numbers in here. 17.5 equals x minus, I'm going to do it the other way around. The big arc minus the small arc. 360 minus x minus x. There's one arc minus the other arc divided by 2. So 17.5 equals 360 minus x is minus 2x. I have negative 2 x's there divided by 2. And now we know how to finish this off, right? What do? Multiply by 2 just like before. Multiply both sides by 2. Those cancel. 2 times 17.5, I get 35 equals 360 minus 2x. Subtract 360. This is just like we did before, right? 35 minus 360 is minus 325. Negative 325 equals negative 2x. Divided by negative 2. And x equals 162.5 degrees. So for that one, all we knew was one angle, and we were able to figure out the rest of the information. All right, questions on that one? That one's a little tricky. Okay. For these next pieces, we're talking now about the lengths of the segments. Not about angles and arcs anymore. Lengths of the segments. I'm going to say segment length. All right, so this can only happen really in 3 different ways. So we can have our 2 segments intersecting inside the circle. And I'm going to call this length A, this part B, this part C, and this part D. So when our segments intersect inside the circle, the way these lengths are going to be related is A times B equals C times D. And the way I remember this is the part times the part equals the part times the part. So one part of this one times the other part equals one part of this one times the other part. And these will be on the formula sheet that you'll have for the test as well. But you need to know how to use them. All right, so there's one way this can happen. Another way this can happen is they can intersect outside the circle. So it could look like this. And I'll call this A, B, C, and D. And the way this works in this situation is that A plus B times B equals C plus D times D. And the way I think of this one is the whole. C plus D is this entire length times the outside, the piece that's outside the circle, equals C plus D, the whole, times the outside on the other segment. Whole times the outside equals the whole times the outside. So that's the second way this can happen. The third way is if we have a secant and a tangent. Are we good? We're good with this one. All right, so our third situation is here. So there's my tangent, and there's my secant. So they intersect outside, but here we have a secant tangent. I'm going to call that A, B, and C. And here we have A plus B times B equals C squared. And I think of this one as the whole times the outside. A plus B is that whole length. The outside piece is the piece outside the circle, equals the tangent squared. And we talked the other day, let's just remember what we said. I'm going to say reminder, because we talked about this the other day. How are these two related if we have two tangents? A and B for two tangents. Do you remember? How are A and B related when these two segments are both tangents? Do you remember we drew in a radius? Drew in a radius. What angle do the radius and the tangent make? 90 degrees. Those are both 90 degrees. We drew in this segment. How are these two related, this segment and that segment? They're the same, they're both congruent. This is congruent to itself. The two triangles are congruent by hypotenuse length, so how are A and B related? They have to be the same. So for two tangents, A equals B. And we talked about that the other day. A lot easier thing to remember than these, right? All right, questions there? All right, I just want to do a couple of examples using these ideas, the whole and the outside and the parts, all that kind of thing. And then we're done. And we can all enjoy our company until 3 o'clock. Maybe 3:05 because you like it so much.
I enjoy your company so much. I look forward to that.
Thank you. All right. Find X. So these are lengths. These are lengths. So we're not talking about angles and arcs anymore. We're talking about lengths. We intersect outside the circle. So our rule, the way we think about this, is the whole times the outside equals the whole times the outside.
This should be the rest of the class.
It's impossible?
Can't have a level of flow.
So you're thinking about two tangents. These two aren't tangents. So you would be right if they were both tangent to the circle, but since they're both secants, it can work that way. Trust me. Good. All right. So what's the whole length for this segment? $25. We add those two together, right? So for this first one, I'm going to say 25 times the outside piece, 11, equals, what's the whole length here? 12 plus x, there we go. You have to add them together. Equals the whole, 12 plus x, times the outside, 12. 25 times 11, 275. Separate the 2 and the 5, add them together, put that in the middle, to multiply by 11. And then we distribute here, 144 plus 12x. And now we're home free, right? Subtract 144. So we get 131 equals 12x, divided by 12, and x equals 10.9. All right, questions there? So be careful with this. When we're finding the whole length on these segments, make sure you add the two parts together. That's a common mistake, is to get confused on that part. All right, last example. And this is tangent here. 9, 6, and x. Find x. Do we have a secant and a tangent here? So our rule here is the whole times the outside equals a tangent squared. So what's the whole length here? 15. So the whole times the outside, 15 times the outside piece, 6, equals the tangent squared, x squared. 15 times 6 is 90, equals x squared. To solve for x here, we square root, and I get x equals about 9.5. All right, questions there? We will have a test on it, a quiz and a test. The quiz for this is a partner quiz. It's a circle puzzle, like our angle puzzles that we did before. This will be a circle puzzle. Finding out.
Those are awful.
Whatever our block day is next week.
I love circle
You
puzzles.
said we ended the chapter on Monday.
Right.
Oh, yeah, we did that on Tuesday.
What? That is bogus.
Does that mean we take the test on Friday?
No, our test is on Thursday.
They said the quiz was on block day.
Block day is Tuesday, Wednesday next week for senior
Don't you
finals.
want to be a nice guy and just give us holidays?
I do want to.
Why don't you?
Why can't you?
No one's stopping
Can I go
you.
get some water?
Yeah, no one will ever know.
And Dr. Anderson will be happy that you're better than his boss.
That one looks so sad because everyone makes it better.
Hey, Dr. Anderson would be impressed.
She'd be like, oh, man, that guy's like a teacher these days.
And this boss would think you're an insane math teacher.